Um, so, test Friday. Take a minute and kind of talk about test format. So, 2 parts. Part 1, 5 multiple choice and 2 free response. Part 2, 5 multiple choice, 1 like regular question and 2 free response. When I say regular question, I mean like a homework question where it's not like parts A, B, C. It's just like, do this thing. Ooh, excuse me. So you guys, this will be like test 4 you've taken with me this year. Some of us have taken more tests than that with me. Let's try to take a moment and guess the kind of stuff that might be topics for these free response questions, right? What have we done here in chapter 4 that would make a good free response question? Or in these last 5 sections or whatever. Related rates, great. I agree. Particularly one that involves an elimination of variables. Right, remember we did the cone one where we had to make the similar triangle or whatever? That feels like a very typical free response related rates question because there's several steps that are along the way that we'd have to do to kind of accomplish that. That makes sense. Would I put a simpler related rates question as a multiple choice question where all you really have to do is do the derivative formula and plug some stuff in? Yeah, I think that feels fair. Or would that fit better, calculator or no calculator? Depends on how simple the numbers are, right? If the numbers were nasty, calculator. If the numbers are real basic, then no calculator. Could land either place, right? It's just about a question of like the numbers I'm giving you to plug in. What else would make, so there's 3 more free response questions, right? What else? Yeah, so mins, maxes, increasing, decreasing, concave up, concave down, inflection point, all feel very natural. Options. And there's probably a couple of different ways you could present a problem like that, right? I could give you the function, right, like the f of x. I could give you a graph only. I could give you or a graph of the derivative or something. Like I could give you just like, you know, like that much information, still ask the same kinds of questions. Or I'd give you a table, right? A table of values from the function or the derivative or the second derivative or whatever, and ask you to do stuff with that, right? Those feel pretty good. And we mentioned last time that like the function that you get, you might see piecewise, right? We talked about piecewise being something that's a good extra wrinkle that we can throw into something that doesn't make it too much more difficult, but like you have to be a little bit careful conceptually. Because what's easy to happen if your function is defined piecewise, if you take the derivative of that, you have to be careful about continuity for the f and then continuity for the derivatives thereafter, right? Because you can have very easily a derivative not existing at values where the pieces change, right? Even if the f is continuous, it's very easy to have like a corner where when you do the derivative, you get a critical value then, other than just where the derivative is 0. Is that okay? So as I'm going through my homeworks and kind of gathering things that I want to make sure I bring with me, I'd probably not want to have like the Encyclopedia El Homeworko and have like 50 sheets of paper, because I'm going to end up spending like a quarter of my time flipping through question after question after question looking for what I want. I'd probably just highlight like, 5 or 6 maybe good examples on these kinds of topics and just kind of try to really not take too much with me so I'm not wasting a bunch of time trying to look for what I need in like a mountain of stuff. Is that reasonable advice? Now, if you want to take a mountain of stuff, like that's fine. If you're like, I'll be fine, I know where everything is. It's okay, good on you. I'm just telling you what I would do. You know what I'm saying? If you did the multiple choice questions, could you bring that? Sure. If you did the free response questions, could you bring those? Sure. If you did the 3.9 questions, could you bring those? Like the AP questions from 3.9? Sure. Right? Like, that's fine. Would I bring all of them? Maybe not, but, you could. Does that help clear up things? Oh, what one topic haven't we mentioned at all? What's the one other big idea that we've talked about here in this set of 5 sections? What? L'Hôpital, yeah. What would make... So that doesn't make a lot of sense as a free response question, because there's not like going to be a bunch of parts to that. But where might that make sense? Just a regular question, right? Just like a regular old like do this kind of homework problem. That makes a lot of sense there. Do we feel reasonably okay about like format for the test and kind of like areas to kind of focus in on a little bit more so? Maybe what to expect when we're running into these kinds of like, okay, I definitely need to know how to be able to do this kind of a problem or that kind of a problem, and hopefully that narrows things down a bit for us. Anthony, Tony.
Even though like justify the mean value theorem a lot.
You should know the hypothesis for like the intermediate value theorem, the mean value theorem, the extreme value theorem. Like what conditions do you have to have in order to apply those? Absolutely. Like which ones need continuity and differentiability? Which ones need just continuity? Which ones, like you definitely would need that, because there will be times where we're, especially in the multiple choice, where you're asked to use those, or maybe times where you need to use be asked to use those in like a free response question. So you definitely would want to know, like, what do I need in order to apply this theorem, and what can I say with it? For sure. Definitely need to know our derivative shortcuts still, right? Those still come up kind of all the time. That never goes away. So like if I ask you the derivative cosecant, you should be able to tell me immediately. Oh my gosh, guys. Nobody? Derivative of cosecant? Oh my gosh, no. Negative cosecant times cotangent. Right? So again, like if you're a little shaky on those, again, like if it's been, I haven't looked over that stuff in a minute, like spend a little time, review your derivative shortcuts, like how you do the product rule, the quotient rule, what all these little individual shortcuts are, run through the Quizlet a couple of times to tighten that stuff back up. Again, that's stuff you never want to get far from, okay? Again, how did I describe it to you? You need to know these so well that like your children will know this. And I know it's obviously being a little facetious there, but like you get the point. So again, if those have drifted on you a little bit, I want to make sure go back and tighten that stuff back up, because at one point you guys felt like you guys really knew that stuff pretty darn well. We've used less of that this unit than the previous one, but we still need that stuff. Okay. Do you guys want to just take some questions from stuff? Homeworks, multiple choices, free responses, any and everything. Probably definitely some 4-4 stuff, as we just did that section last time and haven't taken any questions from that. We'll start with Casey.
Okay. Can you do 71 from 4-4?
Sure. Okay. So we can do this, Casey. I'm going to tell you right now, this is beyond the scope of something I would ask you to be able to do on the test. So I just want to say that like up front. So this is a L'Hopital problem. If I try direct substitution, I have like infinity over infinity, right? So we'll do a L'Hopital. What's the derivative of the top going to be?
Yes.
Okay. And the derivative of the bottom would then be?
Nx.
Okay. Still, if I do direct substitution, still going to be infinity over infinity, right? Okay. So I'm going to do L'Hopital again. If I do direct substitution, still infinity over infinity, right? I'm going to have to do a lot of L'Hopitals, right? Because eventually I have to get this guy out of there. How many more times do I have to do L'Hopital? N over 2 more times, right? I have to get that all the way down to the exponent on the x is 0. No matter how many times I differentiate the top, what's the top going to stay as? Okay. And then what's the bottom going to end up being? N times n minus 1 times n minus 2 times n minus 3 times n minus 4, all the way down to 1, right? So n factorial,
Yeah.
and then times x to the 0, or just 1. Everybody's okay there?
Yeah.
Now, n is a finite value, right? That's something that's fixed. So when I do a direct substitution, I have like e to the infinity over some fixed value. That's infinity. Done. This is an extreme example of showing you that like you can use L'Hopital's rule a lot of times. Does that feel okay?
Yeah.
Now I did a little hand wavy there at the end, but I think it was okay, right?
Yeah.
Would I ask you to do something that's that provy? No. Would I ask you to do something that might involve using L'Hopital's rule 1 time, 2 time, 3 time? Yeah, I think that's fair. N times? No, I don't think I would ask you to do that. Does that feel good? Not as bad as maybe you thought, looking at it. Started with the P word, which I know is scary. What should we look at next? Who wants to go next? 4312a. Yeah, of course. Oh boy, that's not where I wanted that to land. Okay. If you look in that first set of cabinets, there might be one sitting on one of those shelves in there. You're welcome to grab it and use it if there is. I can't remember if I have one in there or not. There's like a little chain at the top of that other door. Oh, you see what? Okay. Sure. Okay, so 12a. It asks us to find the intervals in which f is increasing or decreasing. Now, presumably we're doing this without a calculator, right? Because if you have access to a calculator on here, it's like literally just, they're just going to use the min-max commands on my calculator and just take care of this, no biggie. If we're doing this without a calculator, what are we going to need to do first? I need to take the derivative because I'm going to be concerned about where the derivative is 0, because that's going to be where the function is going to change from increasing to decreasing, right? Because if the derivative is positive, it's increasing. Where the derivative is negative, it's decreasing. So if I know everywhere where the derivative is 0, or I should say doesn't exist, that'll allow me to find those intervals. So start with the derivative. What am I going to need to do to take the derivative of this? Quotient rule. So to do the quotient rule, what do I need to do? It's the bottom times the derivative of the top, or is it the top times the derivative of the bottom? Yeah, that's what I thought. Okay. And then minus the top times the derivative of the bottom all over the derivative, or all over the bottom squared. Okay. So now what I'm going to do is I'm going to look for the critical values. First thing I'm going to do is look at the domain of f and the domain of the derivative to see if there's any places where they differ. So what's the domain for f here? It's a quotient function, right? It's a rational function. So the only values that can cause a hole or a place where the graph is undefined is where the derivative is 0. Where the denominator can be 0. Can this denominator be 0? No, right? If I set that equal to 0 and solve, I get plus or minus I. Doesn't count. So the domain here is all real numbers. Everybody's okay? How about for f prime? What's my domain there? If I look, I have really the same denominator still, right? Does it matter that it's squared? No, it does not. So I get no critical values from the derivative being undefined. I only have to worry about where the derivative is equal to 0. I did some algebra there to clean up the numerator. Is that okay? How do I solve this equal to 0? When is a fraction equal to 0? When its numerator is equal to 0. And because the denominator I know can never be 0, that's all I need to consider is just numerator equal to 0. Is okay there? I subtract 1 from both sides. I divide -1 to both sides, and then I square root both sides, and I get that x can be plus or minus 1. I'm now going to make a sign diagram. I'm going to pick some test values for x. So I need to pick one test value that's less than -1, one test value between -1 and +1, and one test value bigger than 1. Does it matter the numbers that I pick there? No. Just pick stuff that's convenient, right? So if I plug -2 in, well, I know the denominator is always positive, right? Since it's something squared, so I don't even really have to worry about that. So if I do -2 squared, I get a positive number, but then I have to make it negative, so it's -4. And if I add 1, it's still negative. Everybody's okay there? And now where am I plugging in at? The derivative. Plugging into the derivative. If I plug 0 in, I get 0 plus 1 on top. The denominator I know is always positive. If I plug +2, I should get the same thing as -2 because it's x squared. So I see that we are decreasing from -infinity to -1, and then from 1 to +infinity, and increasing from -1 to 1. Does that feel okay there? Should be eminently doable, right? That kind of a question. Not too crazy. Should be able to handle something like that pretty comfortably. Now, if you had access to your calculator, again, could you have found these specific values, what those things actually are, those numbers? Sure, if you wanted to, but you don't need to. I think it's fine without it. Do we need to finish this problem? There's parts A, B, and C. I didn't catch who asked this. Just A was enough, Katie? Okay. What do you guys want to look at next? I'll do any and every, problem that you ask about. I won't say thing. It's like, Mr. School, give me all your money. It's like, hey, here's a quarter. What's up? Oh, what problems did second hour do? We did a whole bunch of stuff in second hour. I don't even remember. We did a bunch of L'Hopital stuff. We did some multiple choice questions. We talked about how to know how to find things on the unit circle without memorizing the unit circle. We did some L'Hopital stuff. We did some max-min stuff, some more L'Hopital, multiple choice questions. We spent a good half an hour at the beginning just asking what if questions about the test. Is that, do you want me to pick? I'll pick one. Is that okay? Yeah? Sure? Let's see, where did that one go? I thought that was a good one. There it is. So I'm going to pick 41 from 4-4. What should I do first? Absolutely. So when I plug infinity in for x, I get infinity. And when I plug infinity in for pi over x, what does that become? if I plug infinity into pi over x, 0 is correct. And what's sine of 0? 0. So that's one of the indeterminate forms. So we're going to need to apply L'Hopital's rule to evaluate this. Can I apply L'Hopital's rule the way this question is currently formatted? No. Why not? Because it needs to be a fraction or quotient, exactly. So how do I turn a multiplication problem like this one into a quotient? You mean reciprocal thing?
Yeah.
Sure. So I can do two options, right? I can do this one, or we could do this one. Is everybody okay with what I did to get these two possibilities? Now, oftentimes it won't matter which one you want to do, but it might. Now, your instinct probably says, let's do the first one, because it seems like that would be the easiest. Okay, let's do that. So L'Hopital. Now the denominator is easy. What does the denominator become? Okay, negative x to the negative 2. What does the numerator become? Does that feel okay to you guys? If I do a direct substitution here, what am I going to get? Still indeterminate, right? Are we okay with how I got 0 over 0? If you don't, you can ask, and I can elaborate, but if you got it, we'll just continue to go. So what do I need to do? Okay, we do it again. Oops. Positive 2x to the negative 3. Now what am I going to have to do to the numerator? It's going to be a product rule, right? Which is starting to look really bad, right? Am I going to eliminate the variables from either the top or bottom here? No matter how many times I L'Hopital this, I'm still going to be stuck with variables in the top and the bottom. I don't like the way this is looking for me. Maybe we should have done the other one. Okay, so what if we L'Hopital here? What does the top become? 1. Oh, right there I know that I would be done because I can't get 0 over 0 or infinity over infinity if the numerator is 1. I like this a lot better. What's the derivative of cosecant of pi over x? Negative cosecant pi over x times cotangent pi over x times negative pi x to the negative 2. Okay, if I do a direct substitution, I have 1 over, what's cosecant of 0? Infinity. What's cotangent of 0? Infinity. What does this become? 0. Yeah, thought that was going to go better for us. Let me look real quick. Did I goof something? Oh, yes. Oh, yes. So dumb, Mr. Kulik. So dumb. You should have said it. You would have looked so smart. You would have been so smart. It would have been like, oh.
No, I saw it and then I was like,
Oh.
it could be crust.
You don't doubt. Like, give it a shot if you think it's like, no, if you think you got something good to say. Like, worst thing.
No, I thought it was not good to say.
Oh, worst thing you can happen is be wrong.
No, because there was a pie in front of it, so I didn't think you could cross it up.
Oh, it's just times, right? Yeah, so if I do that now, then it's going to just turn into, what does it turn into when we do our direct substitution? Pi times cosine 0. Because cosine 0 is? Oh my goodness, guys. I'm so sorry. I can't believe I missed that either. Yeet. But I knew something was bad, something was wrong when I saw this, right? How did I know that was something was wrong? It's another indeterminate thing, yeah. I thought they were all going to, I'm like, oh, and then we'll just all have infinities down here. And it's like, that didn't work. Oh, yeah. Not this exact one, but like this kind of a problem I think is perfectly appropriate. Where you had like an indeterminate form that's multiplicative, you know, like infinity times 0. That feels, you know, pretty fair. Giselle?
You do a related rates problem. It's like something that would be like effort problem.
Oh, sure. Let's look at what I picked. What did we do here? Oh, I'm looking at the wrong thing, dum-dums. There, sum. That's what I was looking for. This one seems like a good one. We love cones. A lot? Any, yes. Why? Because they almost are always on the free response parts of the AP exam. Now keep in mind, like 5 land is like barely 70%. So like you can miss a lot of points and still end up with an excellent score on the AP exam. Even if there's stuff like they don't expect you to know it all. They don't expect you to finish. It's okay. All right. Anyways, that's for another day, though. Let's worry about this one. a cone or a container has the shape of an open right circular cone, as shown in the figure above. The height of the container is 10 centimeters, and the diameter of the opening is 10 centimeters. Water in the container is evaporating so that its depth h is changing at the constant rate of negative 3/10 centimeters per hour. Note the volume of a cone of height h and radius r is given by v equals 1/3 pi r squared h. Find the volume v of water in the container when h is equal to 5. Indicate units of measure. So we know that the volume of water is 1/3 pi radius for the water squared times height of the water squared, right? Oh, not squared. Come on, dum-dum. And we know the height of the water is 5, right? What do we still need for this formula to work, though? The radius for the water. If we have that, we'll have everything we need to plug into this formula. Does everybody agree? How are we going to figure that out? A similar triangles argument. That's exactly right. So if I look at this triangle, it should be similar to this triangle. So I have like radius of water over radius of the container equals height of the water over height of the container. Well, we know the radius for the container is 5. We know the height of the water is 5. And we know the height of the container is 10. Everybody's okay there? I solved that proportion, and the radius for the water should be 2.5. And I could multiply that out some more or just leave it as like, what is that going to be? 25 pi over, 125 pi over 12. Or you could type in your calculator. Or you could leave it the way it's written, with CM after it. So far, so good? Okay. Part B says, find the rate of change of the volume of the water in the container with respect to time when the height is 5 centimeters. Indicate unit of measure. Well, again, I know this is my equation for that, right? And I know from here the radius of the water is equal to, or over 5, is equal to the height of the water over 10. So the radius of the water is 1/2 the height of the water. I just multiplied both sides by 5 and reduced. I need to do that because I need to eliminate the RW in my problem. Let's see, that's because if I differentiate, I'd have to use a product rule, and then I'd get a drdw, or sorry, drdt, and I don't have any information about what that rate of change should be, and I'm kind of stuck. But now, if I differentiate it with respect to t, it's all good. Oops. So far, so good. Sal, are you happy? Okay. And now we'll plug in our 5. And then dH dt for the water is -3/10. And the unit here is volume, so it's cubic centimeters, and the rate was per hour, so it's per hour still. Still feel pretty good? The pace is okay, I'm not going too fast, not skipping any steps on you guys. It then says show that the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. What is the constant of proportionality? Show that the rate of change of the water, okay? That's the derivative of v with respect to t, is directly proportional to the exposed surface area of the water. What's the surface area for the water going to be? It's that circle at the top, right? So pi rw squared. So what I'm going to do is I'm going to take this and divide it by pi rw squared. But what is rw squared equal to? 1/2 hw. So let's see. Pi's can cancel. 1/2 squared is 4, or 1/4. And hw squared is hw. So what are we left with? That's my constant of proportionality. Because I see that v w dt is equal to 4 pi hw squared times dh dt, and my surface area for the water is pi over 4 hw squared. And I think I'm done then, right? I've shown that they're proportional because it's just, what's the difference between them? Just one multiple, a constant multiple. And that constant multiple is the rate of change for the height. Right. Katie. I forgot the H. Yeah, good question. I was careless. Made an oopsies. You caught me. I noticed I did it earlier. I fixed one of them. I guess I did it even before that, though. And I think this is an appropriate level of problem that you'd see on the test. Again, if you're confident on what to do, this was not bonkers complicated. The same tricks we've used a bunch of times, so it should be okay. Do you want to do the other free response one from 3.9 that I'd given you, the lighthouse one? It's up to you.
Can you just like walk me through what you did with C?
Yeah. Okay. So if I want to show that these are directly proportional, so we say that like x is directly proportional to y if and only if x is equal to k times y. That's what directly proportional means, is that there's just the only difference between them is some constant multiple. So that's what I needed to show. So what I did is I took my equation for dv dt that we had calculated in part B. That is this right here. Oh, no. Is this right here. Okay. That's my dv dt. And then I wanted to calculate the surface area for the water. So that's just the surface area for the water is a circle. And then I rewrote RW as 1/2 HW. And when I divided those two, I saw that I do get just a constant, right? That's the same thing as like x divided by y equals k. Or this is like my x, that's my y, and this is my k. So that's kind of what I did there. And then I just wrote it over like a couple of different ways because I wasn't sure for the grader what they wanted, what exactly they needed to see to get all my points. But I'm like, I know how to do this. I know how to what it needs to look like. I'm just going to write it like 3 different ways just to make sure that I get all the points I can out of this problem, in case they were being picky about like what I needed to show directly proportional, whether this right here would count. So I also wrote it like, okay, here's what this is, and this part is just the surface area of the water. So there's like x is equal to y times k. So I'm just like, was just kind of covering my bases there. Does that feel okay?
Yeah.
Cool. Yes, Katie. Correct. Because the surface area of the water is just the circle on the top, right? So just a circle. Does that feel better in terms of like what I did there?
Yeah.
And again, once you hear it talk through, it's like, oh. But the vocabulary is like, takes a minute to kind of sift through like, what are they asking for here?
Yeah.
Like, what's directly proportional? What's the constant of proportionality? Like, what are they asking for? It's like an Algebra 1 thing is why you don't remember. This is a long time ago.
I don't know which
It doesn't matter. Because either way, you'll get then you just get 1 over k, which is fine, right? Like it doesn't matter. You just have 1 over dh dt, which is fine. That would have been fine also. So that's a great question. Yeah. I mean, I kind of knew that the volume was going to be the bigger one, so I just intuitively put it on top, but it wouldn't matter if you had the reciprocals. It's fine. The grader should make no distinction between those two. I would not as a grader. What's next, guys? Some more 3-9 stuff. I know this can be tricky. And it's unfamiliar, right? Which is tough. No? It's okay. I'm trying to help you feel better about what you're going to have to do on Friday, right? Because I come in and everybody looks like they're just in the worst mood possible. And I know some of it's my fault, at least. Christian. 12? Oh, the one that we did way back here? This one? Sure. So part B says then, find the local maximum minimum. Well, I have all the information I need to do part B right here. Since I'm going from decreasing to increasing, that one must be the local minimum. And because I'm going from increasing to decreasing, that one must be the local maximum. So part B was simple because I already had the sign diagram from part A, so there's almost nothing for me to do other than analyze what I wrote down. I love that. And then part C wants the intervals of concavity and the inflection point. Okay, so to do that, I need the second derivative. So to differentiate our f prime, I'm going to need to use quotient rule. So I have the bottom times the derivative of the top minus the top times the derivative of the bottom. To do that, I need to do a chain rule. Oops, and now that's to the fourth. So far, so good. Yuckarooskies. Let's see, I can factor out one of these. And then that's going to leave me negative 2x times another one of those, minus negative x squared plus 1 times 4x. So if I clean this up now and distribute this stuff through, I'm going to have 4x squared minus 2x squared, so that's 2x squared, and then minus 2x minus 4x is minus 6x. So I'll set that equal to 0. Again, it's a fraction, so all I have to worry about is where the numerator is equal to 0 and the denominator is not 0, but the denominator can't be 0 anywhere, so I'm just really need to worry about the numerator. I apply my zero product property. This has no solution to it, as we've established earlier. To solve this, I'm going to factor out a greatest common factor of 2x. So I get 0 and 3 as my possible inflection points. So I'll make a sign diagram. And I'm going to plug some stuff in. So I'm going to acknowledge that this part is always going to be positive regardless of what kind of x I plug in. And this part will always be positive regardless of the kind of x I plug in. So all I'm going to worry about is plugging into like this part. But I'm going to think about it as 2x times x minus 3 because it'll just make the arithmetic a little bit easier. So when I plug -1 into this, I get negative times negative, so that's positive. I plug +1 in, I get positive times negative, that's negative. I plug 4 and I get positive times positive, that's positive. So I see that we are concave up from -infinity to 0, and then from 3 to +infinity, and I'm concave down from 0 to 3. And since I have sign changes at both 0 and 3, where we've gone from positive to negative or negative to positive, both of those are inflection points. So that's it for part C. Again, not too much harder than part 1 was, right? I just did a derivative and did the same thing I did in part 1 essentially again, right? Whoop-de-doo-doo! Now you gotta be careful. You gotta do the derivative right. You gotta make sure you're solving correctly. But like, well within our capabilities, particularly for a problem that was like polynomial kind of everywhere. That's kind of the easiest version of these, is when you just get like polynomials running around. And then it's just like, eh. Now this one might have been a little bit tough because if you tried to multiply this all out and then combine like terms and then refactor, that can be yucky. But if you look for a greatest common factor before you multiply everything out, pretty straightforward if you can manage to do that. And even if you wanted to here, you could do like that reducing if you wanted to. Like that's okay. Now it doesn't matter because they're all positive anyway, so it doesn't really simplify the problem much, but you could do that still. Feel good, Christian? And these ones are like classic AP question, like finding maximums and minimums, and like we like these. They're pretty easy as far as like an AP calculus question goes, right? Like it's still a hard question, but it's like AP easy, right? As long as the derivative's not like super hairy, or the factoring isn't like really clever that I need to do the solve to 0. You know, as long as it's just like, greatest common factors, like, or polynomial, like, I can do that. All right. What else can we do? Happy to do some more stuff. We still got like 20 whole minutes. Without Chanel here, it really like puts the pressure on you guys to ask your own questions, right? Sure. Let's do this then, since you guys are being a little bit passive, and that's okay. You don't have to be like beating me down with your assertiveness. I'm going to use like 28 here as an example. Let's say we want to do stuff with 28. How would I show that 28 is continuous over its domain? So I know that those two chunks are going to be continuous because those two chunks are polynomial. The place where I have a question is at the boundary between them, are they continuous? What do I need to do to show continuity there? I need to show the limit as x approaches 0 of f of x is equal to f of 0. Right? That'll show me continuity at that point. To show the limit exists, so what do I need to have? The left-hand limit has to equal the right-hand limit. What's nice about having to do that for this particular problem? This is continuous, and this is continuous, so I can just do this by direct substitution. Correct? So this should be 4, and this should be 2. Oh, I'm sorry, that's not. This should be 4, and this should be -1. Is that okay? So we don't have continuity here. So it's going to look kind of like this, right? I have a downward facing half of a parabola and then a line with a positive slope. What if I want to find the absolute maxes and mins for f? Well, I'm going to need to take the derivative. So to differentiate f, I'm just going to differentiate each piece, right? So that's going to be -2x and then 2. Now I have to be a little bit careful about our domains. So this is going to go from -2 to 0, but both of those should be open. Why is the -2 now open? Oops. Just because it looks like that, Mr. Kulik. And then something like that. Sorry. The -2 is open because there's no left-hand limit at that point, just as there's going to be no right-hand limit at that point. So those will, by definition, be open when we do the derivative. And then I know the 0 is open because we're not continuous at 0. So my critical values, where is -2x equal to 0 on that interval? Has no solution, right? There's nowhere between -2 and 0 where -2x is equal to 0, right? Similarly, 2 equal to 0, well, that just has no solution everywhere, right? Does that mean we have no critical values? No. We have a critical value. What is it? 0 is in the domain for f, but it is not in the domain for the derivative, because we do not have continuity at 0. So we have one critical value. Everybody's okay with why 0 is a critical value? That continuity check at the beginning was important, right? Because 0 is not in the domain for f prime, but it was in the domain for f. Right? We can't, critical values aren't just where the derivative is 0, it's also where the derivative is undefined, provided that f was defined there, right? Okay. So for an absolute max and min, I need to test my critical values as well as the endpoints on my closed interval, which were -2 and 2. So I'm just going to plug those in for f. And the biggest should be the maximum, the small should be the minimum, etc. Okay? So -2, when I plug that in, I get 0. 0, when I plug that in, I get -1. And when 2, when I plug that in, I get 3. So the absolute minimum value is -1. The absolute maximum value is +3. The absolute minimum is at x equals 0, and the absolute maximum is at x equals 2, just so that we're clear on the vocabulary. If we're asking for a maximum or minimum value, we want the y-coordinate. If we're looking for the location, we want the x-coordinate. Just to be, multiple choice can be picky about stuff like that, right? It's vocabulary matters. And you can't just bulldoze me with all of it and be like, okay, you got it on there. Where if I look at my picture, that should work out, right? Biggest Smallest. That feel okay? What else would be good? Well, let's do one of these things. This can be tricky. We haven't talked about the mean value theorem here. Let's do one of those. Absolutely. Sure thing. So let's just maybe do the first one here. Verify the function satisfies the hypotheses of the mean value theorem on the given interval. Okay, how do I do that? What's the hypothesis of the mean value theorem? You'd want to know this, like, that's the initial conditions, that's the hypothesis, yep. So continuous on the closed interval, differentiable on the open interval. That's correct. Add a little bit more detail, but you had the right idea. Is 9 continuous on 0, 2? Why? It's a polynomial. Excellent. Is its derivative continuous on 0, 2? Yes. Why? What? Well, what kind of function will its derivative be? Also a polynomial, right? So that should be good. That works for me. Now you could show me what the derivative of f is just to verify it's polynomial, but like, that's good enough. Okay. So what is the conclusion of the mean value theorem? It says that there exists C on the interval from A to B such that that's true. So let's start by doing the derivative of f. And then let's calculate f of 2 minus f of 0 over 2 minus 0. So that's 8 minus 6 plus 1, that's 3, and then minus 1. Everybody okay there? So I'm just solving that. So x is equal to 1. Is that on 0 to 2? Sure is. That's my C. Done. How could this be worse? The derivative is nastier, the solving could be nastier, but like that's the gist of it. It's a representatively easy mean value theorem problem. Oh, the other sneaky thing we could do is if you solve this, maybe you don't get an x on the interval, right? You do have to check to make sure it's an available x when you solve, but you know, that could be a mean multiple choice question when they ask you how many c's are there on this interval. So you solve it and you're like, oh, I got 3 answers. The answer's 3. And it's like, oh, wait a minute, one of them's not on the interval. You know, that would be a mean multiple choice question. I love it though. Feels like exactly the kind of thing the AP would put on there. But that's a good one. And again, not too terribly difficult, right? Like symbol pushing or algebraically, that was not hard. You had to remember what to do, right? That's kind of the harder part, is just like keeping the vocabulary straight and like decoding the question a little bit, but the actual process was not too bad. It's not bad. Oh. I am got the sleepies. Here's the good news, folks. After Friday, the only thing you really have to worry about for me will be the final exam. Right? It's the last test. There's no more homework quizzes. We're going to do some more content, but fine, whatever. I can do some homework. Mr. Kulik is pretty flexible about due dates anyway, so I know to like, as long as I get it done at around the time, it's fine. So other than this and the final exam, like that's it for the semester stress-wise for me. So just kind of like keep an eye on it. It'll be okay. You guys have done really excellent work all semester. Okay. Overall, like if you understand the vocabulary, the mathematics piece, the symbol piece for this chapter, I don't think is terrible. It's much more straightforward than last chapter was, where the symbol pushing was pretty extreme at times. But you got to know the vocabulary, right? You got to know like what those things mean and like what they mean in context. You know, differentiable, continuous, hypothesis of mean value theorem. You know, like you got to know that stuff. And that's the longer you go as a mathematics student, the deeper you get, the more your math classes are going to move away from being like the computation is the difficult part to the like, what is this even asking me is the difficult part. And eventually your homework will sound like, you know, this thing with these properties, and then you have this other thing with these properties, show that these two things are related like this. And that'll be what your homework starts sounding like.